Okay, so calculating the TS, I'm actually not going to go through all the formulas and show you all the hand calculations. We are going to let SPSS calculate our test statistic. So if we're doing an independent t-test, SPSS will give us this number. If we're doing a one-way independent ANOVA, SPSS is going to calculate this number. Remember, every hypothesis test is going to come up with a number at the end, and we're going to call it a test statistic. All right? So then, based on what we set up here, what we next need to do is figure out, well, what is the probability of this test statistic? All right? So you're going to, after you calculate the test statistic, you are going to see where this number falls under HO. Remember that we said HO is the working hypothesis. You have to assume HO is true. All your decisions about significant, not significant, retain, reject, they're always made by looking at HO. So we're going to take our test statistic and we're going to see where it falls on a distribution, and we're going to look at a distribution called HO. Now, don't back up. You might be saying, I don't understand. Maybe I missed something. No, you haven't missed anything. In the next slide, I'm going to show you what the distribution of HO looks like, and I'm going to show you how to figure out the probability of this. Okay, so just bear with me. Okay, so how can we figure out the probability of our test statistic? Remember, the reason why we want to know the probability of our test statistic is because that will tell us the probability of making a type 1 error. So what we need to do is we need to plot the test statistic on a new distribution. And this distribution is a standardized frequency distribution representing HO. And once we plot this on HO, we're going to find the area under the curve. So that may not make much sense to you either. Let's bring up a picture. What is this HO distribution that I keep referring to? Well, HO, remember, says null, none, and nothing. HO is saying, look, you can get values of your test statistic. And those test statistic values may still just represent sampling error, right? Because that's what HO is. It's basically saying you have sampling error. So a test statistic, regardless of how big or small it is, or whether it's negative or positive, could still just be saying, look, it's just sampling error. Some of the values of the test statistic are going to be right around 0, and those are high probability events on HO. In other words, we could get a test statistic around 0, and it's a very likely possibility that this is just sampling error. But if we move out into the tails, according to HO, these large negative test statistics or these large positive test statistics still belong under HO. In other words, they may be very unlikely events, but hey, they still belong to me. All right, that's what HO is going to say. So the distribution of HO is nothing more than the distribution of test statistic values, TS values, that you could get that reflect just sampling error. So in theory, because this is all hypothetical, but in theory, this distribution goes from negative infinity to positive infinity. So if HO could speak, it would be saying, look, you can get a test statistic. I don't care how big or how small. I don't care if it's negative or positive. You could get a test statistic of any size, and it's still reflecting null, not a nothing. It's still reflecting sampling error. All right. Now, if we look, if we get a test statistic right around 0, we would agree and say, hey, that's a high probability event. That probably is just sampling error. But what if we get test statistics way out here or out here? Then we might choose to disagree with HO and say, I don't know about that. This probability here of my test statistic, this probability is so small, I think you could be wrong, and you might then reject HO. All right? So what you're going to do is you are going to take your TS that you found, and you're going to see where it falls on this distribution. And if it falls anywhere in the middle, then you're going to say, yeah, I guess it is just sampling error. But if you get a test statistic way out here in the tails, you're going to say, wait a second here, it could belong to HO, but maybe it doesn't. I better reject HO. All right? So again, the HO distribution is simply a plot of all your TS's. All the TS's that could potentially happen that reflect nothing more than sampling error, which means you're plotting every TS possible in the US, in the US and the world and the universe and beyond, past, present, and future. Because according to HO, any test statistic, no matter how big or how small, could still be reflecting sampling error. Okay? All right, so this is just a reiteration of what I just said because it is important. So remember that HO is saying null, none, and nothing. What is the HO distribution? Well, it's just a distribution of our TS's, our test statistic values. These are just hypothetical, and it's telling you what is the probability of getting a test statistic, let's say this size, when HO is true. We could actually figure out the probability of this. What is the probability of getting this test statistic over here under HO? What is the probability of getting a TS value this big and it still be just reflecting null, none, and nothing, sampling error? All right, so what you're going to do is you're going to look at your SPSS output, and it's going to give you a TS value, right? You're going to get a TS. And then you're going to say, okay, well, where does it fall here? All right, where does it occur? Because if it occurs here, if it falls anywhere close to 0, then you know you probably just have sampling error. But if it falls way out in the tail, then that suggests that maybe you can reject HO and say, I have got something. So how are we going to know where our TS falls and what the probability of our TS is? Okay, so that's the first question. How do we know, or second question, I guess, how do we know what is the probability of our test statistic? Now, if you are using SPSS, the answer is so easy. All you do is you look at the output and you look for the sig value. So it'll say sig. And then there's going to be a number beside it, right? So, or under it. So it'll say sig is, and then 0.002 or 0.000 or 0.128, right? It's going to give you a number here. And then all you have to do is recognize that that is the probability of your test statistic. Okay, so the sig value is the probability of your test statistic. If that sig value is less than 0.05, then you're happy. Because remember, the probability of our test statistic is the same thing as the probability of making a type 1 error. So if our sig value is less than 0.05, that means the probability of a type 1 error, if we were to reject HO, is also less than 0.05, right? Those two things are the same thing. So if it's less than 0.05, you can reject HO, your results are significant, and you're comfortable because you know that the risk of a type 1 error is less than 5%. If you're very conservative, all right, you don't like making mistakes, you're very conservative, then if this sig value is, let's say, 0.05, you may say, okay, that's wonderful, but I'm not comfortable with that. That's too risky. I am only going to say something is significant and reject HO if the sig value is less than 0.01. All right, so if the sig value is less than 0.01, then you reject HO. All right. And whatever that sig value is, remember that is the probability of your, test statistic. Oh, over here. So your test statistic that you calculated, or SPSS, that probability is the sig value. And the sig value is the probability of a type 1 error if you reject HO. Okay?